All right, let's take a look at homework 3 to kind of help you get going here. So problem 1, you have a geothermal pump. It's pumping brine whose density is given by 1050 kilogram per meter cubed at a rate of 0.3 meters cubed per second at a depth of 200 meters. It has an efficiency of 74%. Determine the required power input to the pump and assume the geothermal water at 200 meter depth is exposed to the atmosphere. Okay, so what you need to remember is that the efficiency, right, is the change in mechanical energy over the pump power. Okay, so from the previous homework, you've written out what delta E is, right? Is the mass flow rate times your delta E. Okay, where this could be potential, kinetic, and in this case, it's at a depth. There's no velocity given. Okay, so this will primarily be one energy. Okay, so once you find that, right, you can find this, you have this, you can solve for that. Okay, now in this one, you have an oil pump is drawing 44 kilowatts of electric power while pumping oil with a density of 860 kilograms per meter cubed at a rate of 0.1 meter cubed per second. So the inlet and outlet diameters are 8 and 12 centimeters. If the pressure rise of the oil in the pump is measured to be 500 kilopascals and the motor efficiency is 90%, determine the mechanical efficiency of the pump. Okay, and then create a computer program to solve this. All right, so what you need to realize is there's actually two cases, right? You have the motor coming in, and then this goes out. Okay, so this output power is then the input power to this pump. Okay, this input power, 44 kilowatts, this motor has an efficiency of 90%, which has an output, which is also then the input to the pump. Okay, so you can find that with this 90%. Okay, and then you got to realize that the efficiency, right, is the mechanical energy over the input of that pump. Okay, so this is what you're looking for. This you have based on the motor, right, that I just talked about, and we know this already, which is, there should be a dot up there too, mass flow rate times delta little e. Okay, now this you have to break down, right? There's out minus in, and in this case, this you need to expand. It's going to have pressure, right, P over rho, or P times little v. It's going to have kinetic, and it'll have potential. Okay, it could. In this case, this change from here to here is neglected, so there is no potential. Okay, so I hope this helps with homework 2. Let me know if you have questions. Thank you.